Welcome back. In this video, we're going to finish our review of fractions by talking about how to solve equations that have fractions in them. So as a starting point, I want to look at this equation. Now, here's the punchline at the end of the day. The punchline is, if I want to know when a fraction is 0, I only have to look at one thing. Namely, I only need to look at the numerator. This should remind you of the first section, where we really emphasized that something being equal to 0 is very special. It behaves differently than the same thing being equal to anything else. And so here, what I'm telling you, the punchline here, is that if I have a fraction equal to 0, I can ignore the denominator completely and only look at the numerator. Now, you might ask, and it would be a good question, why? What am I really doing? And here's what you're really doing. You're really saying, okay, I have this fraction here, and what do I want to do whenever I have a fraction? Whenever I have a fraction, I want to get rid of the fraction as quickly as possible. And so the way I'm going to get rid of this fraction is by multiplying by x squared plus 1. So in fact, what's going to happen is I'm going to multiply both sides of this equation by x squared plus 1. When I multiply the left-hand side by x squared plus 1, it clears out this denominator, and so I'm just left with x squared minus x minus 6 equals, okay? And when I multiply the right-hand side by x squared plus 1, I get 0 times x squared plus 1. But 0 times x squared plus 1, much like 0 times anything, is just 0. And so I get x squared minus x minus 6 equals 0. And so often you'll think of this as, oh, I'm moving the x squared plus 1 to the other side, but you really want to think about what the operation you're doing here is. And I'm trying to undo division. The operation that undoes division is multiplication. And so I multiply both sides by x squared plus 1, which then amounts to multiplying 0 by x squared plus 1, but that just leaves a 0. And this would work equally well for any denominator that you could have here. But at the end of the day, you don't have to think about this. You only have to think about, I've got a fraction, it's equal to 0, what do? I look at where the numerator of that fraction is equal to 0. That's how I solve it. And so as soon as I realize that, I'm back exactly in something that we talked about in the first video, where we just factor this, and so this will factor as x minus 3 times x plus 2 equals 0. And so split that into pieces. That gives me x minus 3 is 0, and x plus 2 is 0. And so I get x is 3, and x is minus 2. And so these are my two solutions to this equation that I started with. Next up, I have this equation. So the sum of these two fractions is 0. What's x? And there are two different ways that I can approach this question. And you might have seen each of them before, so I'm going to show you both ways, and I have no preference between the two ways. You can do it whichever way you want. So the first thing we can do is to combine these two into a single fraction. That single fraction will have denominator 1 minus x times 2x minus 1. Okay. And when I go to put this 2 over this denominator, I'll have to multiply it by 2x minus 1, minus. And when I go to put this 1 over a denominator of 1 minus x times 2x minus 1, I will need to multiply it by 1 minus x. This is exactly what we did in the last video when we were combining fractions. I'm just combining these exactly like that. So I'll continue with my algebra. 4x minus 2 minus 1 plus x. Don't forget to distribute this minus sign in there. And so this will be 5x minus 3 divided by 1 minus x times 2x minus 1 equals 0. How did that help? Well, I now have something that looks like fraction equal to 0. And so if I remember my punchline from before, if I'm looking for where a fraction is 0, I want to look for where the numerator is 0. So I completely ignore the denominator, and I just say 5x minus 3 equals 0. So 5x is 3, so x is 3/5. And that is my solution. I encourage you again, when you get this solution, you can check it by plugging in x equals 3/5. And it's good practice to make sure that when you plug in x equals 3/5, you really, in fact, get 0. Okay, so this is one way to solve this question. But as I said, there's an alternate way to do it. And the alternate way is to do something which is called cross-multiply, which is something you have probably heard of before. Okay. So before I can cross-multiply, I actually want to rewrite this original equation as 2 over 1 minus x equals 1 over 2x minus 1. And so this idea of cross-multiplying, it actually works when you have a fraction equal to another fraction. In no other instance will it work. In particular, you have to be solving an equation to even think about cross-multiplying. So if you're simplifying, this isn't going to help. But why is it called cross-multiplying? The reason why it's called cross-multiplying is that we can replace this equation with fractions with an equation where we multiply these two things and set that equal to what we get when we multiply these two things. And the cross, this is the cross, this little like red X here. Okay. So I'll get 2 times 2x minus 1 equals 1 minus x times 1. And so this will be 4x minus 2 equals 1 minus x. Okay, I'll move this x over, which will give me 5x, this 2 over, which will give me 3, and so I'll get that x is 3/5. As promised, we get the same answer both ways. And not only do we get the same answer, we got it in roughly the same amount of work, although you could argue we actually wrote down a little bit less over here. So take your pick between these two methods. They should both get you the same answer. All right, I want to do another example of cross-multiplying, just so you have a couple to look at. So here I have fraction equals fraction, so I can multiply them across like this. And so I will get x times x minus 1 equals 4 times x plus 6. So I will get x squared minus x equals 4x plus 24. And now here's the other reason I wanted to do this example. Note, I'm no longer getting a linear equation. In the last example I did, in this example, I ended up solving 5x minus 3 equals 0. Actually, sort of either way I did this. I ended up solving this linear equation. In this case, I actually am ending up solving a quadratic. So I want to push everything over to the left. So this will be x squared minus 5x minus 24 equals 0. And what do I do to solve quadratics? I factor them. So I will factor this. And so this will work out to be x minus 8 times x plus 3 equals 0. I again split into these two halves, and I'll get x equals 8 and x equals minus 3 as my two solutions to this equation. If you want to check one of these answers again, all you have to do is plug that in. So if I plug in 8, I would get on the left-hand side 8 divided by 8 plus 6, which is 8 over 14. which is 4 over 7. Whereas on the right-hand side, I would get 4 divided by 8 minus 1, which is 4 over 7. These two things are the same, and so 8 really is a solution. I'll leave it to you to check that minus 3 is also really a solution. Okay, so we've talked about two ways to solve equations with fractions. One of them is to moosh all the fractions together into one fraction that's set equal to 0, and then just look at the numerator. And the other is to cross-multiply. Looking at this equation, there's a way you can tell that cross-multiplying isn't going to work. Namely, the only way cross-multiplying works is if you have a fraction set equal to a fraction. But here I actually have more terms than that. Namely, I have this fraction, and this number, which is also really a fraction. So because I have 3 fractions, there's no way I can do this problem without combining at least 2 of the fractions. So instead of worrying about that over much, I'm going to just combine all 3 of the fractions and do this the first way we talked about. So, namely, 2 for x minus 1, x plus 3, and I'm going to move this minus 1 over to get plus 1 equals 0. Okay. And so if I can rewrite this all as one fraction, it'll be equal to 0, and I'll be happy. To add these 3 numbers together, and really I'm thinking of this now as a fraction, so I'm mentally thinking about it as 1 over 1. To add these 3 fractions together, I need to find what the common denominator is going to be. And the common denominator in this case is going to be x minus 1 times x plus 3, which is a multiple both of x minus 1 and x plus 3, and also a multiple of 1 because everything is a multiple of 1. And so when I go to write all of this over the denominator of x minus 1 times x plus 3, I'm going to have to multiply this 2 by an x plus 3. I'm going to have to multiply this x by an x minus 1. And actually, this 1 over 1, it has neither an x minus 1 nor an x plus 3 in the denominator, so I'm actually going to have to multiply it by the full x minus 1 times x plus 3. This looks kind of messy, and it is kind of messy, but I've at least reached my point where I have a fraction, it's a single fraction, it's a messy fraction, but it's a single fraction, equal to 0, which means I can just sort of discard the denominator here. So I'll just have 2 times x plus 3 minus x times x minus 1 plus x minus 1 times x plus 3 equal to 0. And now I just have to simplify this, and then I will get to what my value of x is supposed to be. Okay, now I have to collect terms. So I have a minus x squared and a plus x squared, so those in fact actually cancel. Then in terms of x's, I have 5 x's. And then in terms of constants, I have 6 minus 3. So that is, I have a plus 3 here, equals 0. And so I can rewrite that as 5x equals minus 3, and then rewrite that to get x equals minus 3/5. That is my answer to this equation. All right, we'll wrap up talking about fractions there. And in the next video, we'll be talking about the rules of exponents. But until next time, be well.